Hello everyone, this is Harmandeep Singh, code name 6933, making Mill Project 2 in the same mastercam file as the Mill Project 1. So as I can show you all my toolpaths here, it's for the Mill 1 project. So you have to rename Machine Group 1 to Mill 1. And let's go on our levels real quick. So all my levels, as you can see, the 100th level for mill 1, 101 for wireframe, 102 for solid, 103 for name. The 100th one is just for the heading, and all of these have their own entities. So the wireframe has its own entity, and if I remove it and give the name has its own entity too. So same you have to do with the mill 2, 200 for mill 2 for the heading, and 201 for the wireframe, 202 for the solid, and 203 for the name engraving. So this is what you have to do. If you didn't make the levels for mill 1, just leave it. You don't have to make the levels again and complicate things. All you can do is just start with the level 200 for mill 2 project and continue with these levels. Okay, so I already selected the wireframe one since I want this level to be active, and we have to go to the planes real quick and select a new plane relative to VCS. So hit top, and now you have to rename it. I will give it mill2 OP OP1 operation 1. Okay, and it says that there's my negative, so I need 10 to the positive since I'm going to the top now, and I don't have to link any of these, so hit tick since it shows me that it's all linked. So what you have to do is unlink all and select this one, and now hit add it again. So you have to change it to 10 again. Okay, so as you can see now, there is a difference in here. The Z offset is to the top of 10. Okay, and go to the levels real quick. See my all levels are okay. All the toolpaths, minimize it, and we have to make a rectangle first. 3 by 3. Okay, arc to center, click, tick, need a new one, 2 by 2, right here, and then I need a new one. Uh, uh, so this one is for this one. Okay, so this one is for this one, the bigger one, 2 by 2, and for the smaller one, I'm gonna show you what smaller one has it. So the smaller one is 7.7 05 into 2. Just 1 second, let me see. Okay, so the first one's width is 0.750, 0.750 into 2, enter, and then this one is 0.875 into 2, enter. So this is our third one, the smallest pocket. Hit tick, we already got them, and now we have to make some chamfers here, here. The chamfer is 20,000. Tick. Oh shit. Just 1 second. Chamfer. Um, escape. Escape real quick. Mm-hmm. Chamfer. That's here to here, here to here, here to here, here to here. I already got my all chamfers here. Okay. Now what you have to do is make all your holes here. So one, two, three. these holes have a same about coordinates, location is same, and this hole is different. So what you have to do is put the diameter here. So the diameter is this, and then you have to lock it. Wait a second. Um, Hit escape. Now here you have to make your holes. So what I'm gonna do is I'm gonna tap here 1 point. Oh, it made a wrong hole here. Just leave it. We will make a new one. Um, minus 1.125, comma 1.125. Enter. 1.125, comma 1.125. Enter. Hole is right here. And for the second hole, minus 1.125, comma 1.125. Enter. So our second hole is right here. Now the third hole. Um, 1.125, comma minus 1.125. Enter. So we got all our three holes. This hole is just garbage. We are going to delete it. But first you have to make the third hole here. So the coordinates for third hole is minus 1.075, comma 1.0, comma minus 1.075. So these are the four holes. Hit tick, and now we need a different diameter here. 1.125 diameter for small holes, and the coordinates is 0, comma 1.250. Enter. 0, comma minus 1.250. Enter. So these two holes we already got it, and now we need some more holes here, 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 here. Let me do divide real quick. Okay, so this is all good, and now we are going to make one more hole here. 0.25. It's for this, for here. Oh, so the diameter is the wrong hole, I believe. So the radius should be different. 0.25. Enter. Yep. So the radius is 0.25 for this one. And then we have to hit tick, and then the new hole, which is 1 inch for here. And the coordinates are um oh, mistyped it. Let's leave it. We are going to delete it again. I believe it's minus 1.05, comma 0. Enter. Yes. So hit tick now. And which holes? Okay. So we need holes here, 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 here. Um. So I'm just gonna hit tick real quick and divide these. I don't need this, 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 and I don't even need these. Okay. Okay. So this is somewhat close, and now the other holes. So the radius for those holes is 0.15. Uh, don't place it here, okay? The coordinates are different for these ones. So the coordinates are minus 0.908 comma 0.908. Enter. So this is right here. Now it's time for the second hole. Should be right here. The coordinates are about same. The only thing is different. That's the quadrants. 0.908 comma. So 1 second. So I have to hit enter here, I believe. Enter. 0.908 comma 0.908. Enter. We got another hole. So the another hole, the third hole is around here. So it is 0.908 comma minus 0.908. Enter. Okay, we got all our holes. Hit tick, divide, remove excess wireframes. This one. Oh, Control Z. Okay, so it's halfway done now. What you have to do is use some fillets here, the radiuses. Um, so the radiuses are 0.15. Okay, so radius here, radius here, radius here, radius here, radius here, radius here, and there is a different radius right here. We got one, two, three, four, five, six radiuses as shown on the drawing. Now the second one, the radius should be 0.5 for this one. Okay, and hit tick. And now the other radius that we need is around 300 thou, which is this one. And I don't think we need any other radiuses. So this is our complete wireframe. This is our complete wireframe with all the chamfers and everything else. Um, yep, yep, everything is all good here. So what you have to do now is go to your levels. You see my wireframes, they have 36 entities right here. And I'm going to now move to the name engraving part. So hit create letters. So write your name. I'm going to write my name real quick. If you want to write your full name, you can, but it's just a sample drawing, so I, I'm just making it quickly. Point 1, 2. I believe they should be good. Yes. So this is my name, and we have to make a new name here too. Uh, it's for the it's for my student number. Oh, not arc, horizontal, base reselect right here, tick. So my name engraving now has 143 entities combined. Okay, there is if I try to hide it, you see, or if I try to hide my wireframe. Okay, so these all are in a plane of mill2 operation 1. Now what we have to do is we have to go to our machine now. At top, we need a new machine group. Why I'm saying this is because all this machine group has operations for mill1 project. So for the mill2, you have to take a new machine group. And some of you guys don't have this file in their library, since most of you guys use Georgian College monitors to make this files, so that would be okay. If you're making it at the home, you can choose default. Okay, and next thing you have to do is go to files, program number. use your last four digits of your student number, and then select uh, aluminium 6061, and then go here, assign tool subsequently, warn of duplicate tools, and the next thing you have to do is save. Forgot to tell you, but you have to save your whole drawing. Save it. Now go to bounding box, all shown. Okay, so Z should be zero point 0.5 and X and Y should be 3.1. 3.1. Okay, so everything is else is done. So you can see my origin. So Z is to the plus 10. It's because our offset is plus 10 too. What you have to do is add 0.005 thou to it so that our stock can move to the top. Now, you might not be able to see it, but as you can see here, our stock is 5,000 to the top now. Hit tick now. We already got our stock. Go to toolpaths. If you want to see it, you can. Let me hide this one real quick. Okay, I only need this. Toolpath 1, mill 1. So we are going to rename this to it's F first operation. Enter. So this is our first operation. What we have to do now is go to the top, dynamic mill, from outside machining region, this one, reverse it clockwise for the outside and anti-clockwise for the inside. Just remember it. So this is clockwise, so we have to use this one. Okay, from outside tick tool, not 3/4. We need 3/8. 3/8 flat end mill. Okay, and SFM should be around 450. Feed rate is okay. Feed per tooth should be 2000. This should be good. Cut parameters step over should be 75% because it's gonna save you a lot of time. Stock leave on floor 0. Stock leave on four walls doesn't matter. You can zero it or not. Clearance I always take 1. Depth there is no need. Choose absolute, absolute, and plane should be mil to operation 1. Coolant on. You can always do coolant on. If by chance you can go to the mini mills, you don't need to on and off the coolant again and again. You can just put it into your program. Okay, hit tick. So this is our first one. I'm not gonna show you the video of this because we are quite short on time, as I said. So now what I'm going to do is hit counter for the outside chain. I need this one. Hmm, tool. I need 3/8 same tool. SFM around 400 since we are finishing it. It doesn't matter. Let's put 450. Feed per tooth 1000. Lead in, lead out on, but entry on exit on midpoint. Now cut parameters, everything is all good. Clearance, always take 1 inch. Depth, no need. Absolute, absolute, absolute. Planes, this. Coolant off. And I should have told you that you have to write what you are doing in this operation here. It's gonna help you a lot. So I am doing sidewalls here. Squaring, SQUAR, square. That's what I will put here. And on the first one, 1 second. In the first one, I will put here facing. Okay, I'm doing facing in this one. Okay, it will show you right here, square and facing. Okay, now it's time for the third operation. Now it's time for this pocket here. Yeah. So now it's time for the pocket. This one, as you can see in your drawing. So what I'm going to do is use dynamic mill again. Machining region, this one. Uh, so we are doing it inside. So we don't need it clockwise. We have to make it anti-clockwise. And then stay inside. Take tool, same. SFM should be around 450 feet per tooth, 0.002 thou. You can use depth of cuts here, but I am not very much aware of depth of cuts. You just have to confirm it with your professor. Okay, this is all good. Think I can leave stock on walls around 20 thou. Clearance is all good. Entry and exit point, no lead in, lead out. Everything is all good. Coolant is on. Okay, I made the third operation and now I have to hit counter here. Same as the previous one. Tool. Now be very careful since there are radiuses around here and here. So what you have to do here is select a 1/4 inch flat end mill. And now SFM is around 400 150 feet per tooth, around 1 since we are finishing it. And lead in, lead out, everything is all good. Lead in, lead out, entry, exit on midpoint, no. And just to let you know, hit it 75% perpendicular. Same here. Linking parameters. Oh, forgot to give it a depth. Depth should be minus zero point 0.5 with the breakthrough of 60 thou. Okay. This is all good. Coolant on. Planes. Everything is all good. This is good. This is good. Tool. Here's finishing pocket. Okay. Everything is here is good. And in the dynamic mill, you have to uh, make the depth here minus zero point 0.5. And in this counter, we are using lead in, lead out, so perpendicular length should be 75%, just to be very precise. Okay, this is all done. Now, what we have to do is drill all these holes. We already done the facing. Drill. So the first hole, second hole, third hole. Just 1 second. Let me delete this one. This hole, and this hole. We're going to make a separate file for all of these. Tool we are going to use is spot drill. This one. Spot drill should be 1/2 inch spot drill, right? Let me see in the tool required for, yes, half an inch 90 to 188. That's okay. Make it 75. Spindle speed is too small. Uh, let's make it at least 1,000 feet per tooth. 1,000. Okay. Cut parameters. Drill. No need for pack drill. Linking parameters. Just put your overall diameter. What is your overall diameter? It's finished diameter is this one. Override depth. Here. Clearance. 1 inch. Always in absolute, 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 absolute. No tip comp. Coolant on. Planes the same. Torque is okay. This is okay. Here's spot drill large holes. Here we go. So this is done. So what we have to do now is we have to copy it. Copy here, Control V, paste parameters. Go to toolbar type. We need a spot drill for these two holes, and about for the linking parameters, go here and put 0.125. Enter. Here we go. This is all good. Coolant is on, everything is okay. This is done, and now we have to uh, copy this one. Copy, oh, paste parameters. We need a new tool here, which is a drill. So let me see which drill we need real quick. 1364th. It's around 1111. Yep, 7 1364th drill. Right here, we are going to select this one. Make it 150. Should be good. Yep. Cut parameters. Pack drill. Always. Linking parameters. Everything is all good. Depth should be minus zero point 0.5. Okay. And use tip comp always. 3,000 would be 30,000 would be enough. Coolant on. Planes is so good. And we are going. Yep. Spot drill. Just cut the spot one. Drill large holes. Okay. And we are going to um, copy this one again. Control V. And we need a new drill here. So we need a 764th drill. 764th drill here. Yep, this should be 150. Okay, cut parameter spectral uh, machine geometry. Oh, crashing. Oh my god. As you have seen that my Mastercam file crashed, so I made it again, and let's do some modifications that we were left with. So 764th drill, all these feed rates, this should be 70, okay, and this should be 1000, and my geometry is these two holes, okay. And about the cut parameters, choose spectral, and clearance should be 1000, and then the depth should be minus zero point 0.5. Everything should be absolute, and tip comp of 30,000, and then hit planes mel 2 operation 1 perfect, coolant should be on, everything is okay. Now name it as drill small holes. Okay, enter. So this is done. Okay, and now we are all holes here, 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 here. All these holes have been drilled. We don't have to make the large pocket, it's on the other side. We have done this. Yep. And the only thing that's left is, I believe, the name engraving. Yep. The name engraving and the chamfers. So now hit counter. So this file is different from the other one that's been recorded previously. This one has all the capital letters. So I had two sample files here. So just go to your levels, deselect the wireframe, select window like this, go to your tools. I always prefer a ball nose and mill, 1/8 ball nose and mill, because this is more sturdier and better than number 2 center drill. I will take 150 as SFM, feet per tooth around 1 inch, since it's going to make just a small cuts there. Lead in, lead out always off, cutter compensation off. Okay, tool I selected it, linking parameters, clearance 1.0, and I'll tell you one more thing, depth should be minus 0.003, enter, and always use only at the start and the end of the operation because it's gonna save you a lot of time. There is no breakthrough here, okay? Plain, coolant should be on, everything else is done. So we already got our name here, everything else. Now we need counter. So the counter for this, there should be chamfers around here somewhere, but this file doesn't has it. Okay, so counter this one and this one. Okay, so let me remove it. So this arrow is going clockwise. It means it will go outside. This arrow should be inside because it should be anti-clockwise because we have to machine it from inside. Okay, and then the tool. So our next tool is going to be a chamfer mill, quad range chamfer mill. Speed around 150 again. Spindle speed is okay, everything is all good. Cut parameters should be computer. This should be 2D chamfer. Chamfer width is zero point 0 20 thou, and bottom offset should be 0.606 60 thou. And then there is a lead in lead out function. Always hit perpendicular, and length should be 75. Same here. Linking parameters, everything is all good. No need to put the depth here, and remove this. Plane is all good, coolant is on, so we got our chamfers here. We are not using our tool paths, we are not showing our tool paths here. I will show at the end, but according to me, all these programs are perfect. Okay, now we have to copy it and control V as a paste. Now remove these two and use these all. Okay, oh, this should be at the top, should be anti-clockwise, all of them. Okay, hit tick. Let me see real quick. Yeah, they are all inside, and we are going to use the same machine here, same drill. Everything is same, lead in, lead out. I think there is no need for lead in, lead out in the holes. Linking parameters and depth is all same. Coolant is on, and okay, cutter compensation not successful. Let me see what happened. Hmm, Bottom offset. Okay, this is all good. Okay, so the problem is we haven't made it zero. Should be pointy. Okay, yeah, update to all tools. Okay, regenerate everything. So now our chamfers will be good. Just make sure that the drill should be pointy. There's there should be no cutting there. Okay, so we completed our first operation here. So now we are going to make second clamping here in this mill project. So first you have to make a new plane here at bottom, and oh, we have to rename it real quick. Mill 2 operation 2 and unlink unlink it, and then go here and then go to edit. So now you have to minus how much is your finished stock. So it's 0.375. Okay, so this is your end product of Z axis. You can see now my Z is um, above the wireframe. Hit tick. So this is our new plane here. Go to levels. Levels are all good. Toolpath. You have to create a new toolpath here. So go here, up here, right click, groups, new toolpath group. Just rename it real quick. Second clamping. Okay, this is second clamping. So you have to face it first, right? Hit dynamic mill from outside machining region. This one, reverse, and this is good. Go to tool, select flat end mill. SFM should be 450. Feed per tooth, how. Name it as facing. Okay, and everything is all good. Cut parameters, floor 0, stock leave on walls should be 02 since we don't have any walls on the facing operation. Step over, hit 60 this time because we are taking more stock, more material than the previous facing. Now go to linking parameters. Clearance should be 1 inch, and everything should be absolute. No breakthrough. We don't need it. Plane should be this one. Coolant on, and this one is good. So for now, the second part, we don't need any counter here. We just have to make this second pocket, the large one. So hit dynamic mill again, machining region. So now we have to select it to the opposite side. So it should stay inside now. Stay inside. Tick. Now you have to go to tool, select flat end mill again, and SFM. 400, 400 for this one. Feet per tooth around 2, since we are just roughing it first. Cut parameters, it's all good. Stock leave on walls should be 20,000 this time. Okay, step over is all good. Linking parameters is all good. Depth. So the depth you have to change it. Um, just check your drawing real quick. It should be say here minus 0.188. This is your depth. And I'm not sure about the top of the stock. What is it? But just consult with your professor what he thinks about this, and everything else is okay. Coolant is on, tick. So we got our uh, the pocket roughing too. Now we are going to make a finishing move here. So select previous and go to your tools. Now you have to select quarter inch flat and mill. Since it's not the 3/8 one, not gonna rough these holes here. So SFM should be around 450. Oh, 450. Um, feet per tooth should be around 1 thou. Feed rate around 25. This should be good. Cut parameters, computer, no 2D chamfer, just 2D. Lead in, lead out, you can use it. I would prefer to use it. Clearance is good. Depth should be 0.188 again. No breakthrough. Planes is all good. Coolant should be on. So we got our this operation too. So everything is done. Now we have to counter it. The chamfers outside here, here. Okay. So now hit counter again. Chamfers here. Um, this is clockwise, so the arrow would be outside. This is anti-clockwise, arrow will be inside. Hit take now. You are using 1/4 chamfer mill this time. Take it as 150. Uh, take 1.5. This should be good. Cut parameters. 2D chamfer here. Lead in, lead out. Yes, we need lead in, lead out for these ones. There is no harm to not to use it. Depth should be 0. Okay. Mm, Plane. This is all good. Coolant is on. Tick. And we are going to copy this operation and paste it again. So just go to your chain real quick. Now select this one, hit reverse. It's a little bit on the bottom side, so we have to add depth into it. Select lead in, lead out. It's all good. Tool, chamfer, everything is all good. Linking parameters, depth should be minus 0.188 for this one. No breakthrough. Planes and coolant is all good. And now we have to make a toolpath for these holes too for chamfering it. And hit counter again. Just 1 second. No, we don't need it. Select, then copy, then paste. The only thing you have to do now is go here, Change geometry to the top, 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 to the top. Oh, reverse. So this is going clockwise. So, oh, my bad. I have to reselect them. Should be anti-clockwise, all of them. Okay. So now if we check the direction is towards inside. And now go to tool, everything is okay. Here too, lead in, lead out, 2D chamfer, everything is okay. Depth should be 0 for this one. Coolant is on. Okay, hit tech. The last operation that's left is reaming for these holes. Okay. Um, so let me see. Yep. So the reaming is this side. So go to drill, select both of these. You see, it shows me the diameter. So the location of these holes and the diameter is okay. Hit tick. Now we have to use back drill tool. We have to take a new tool from here. Filter out reamer. We need 1/8 reamer, 0.125, which means we have to change the feed rate to 75. This should be good. Mm, cut parameters is okay. Linking parameters depth should be minus zero point 0.3, 300 thou. Okay. No tip comp for this one. Clearance is okay. Retract and top of stock is okay. Planes is all good. Coolant is on, and we completed our whole project. So I'm not sure if I can show you a full drawing of this, but I can try to show you because this is a sample drawing. There's a lot of changes that I need to do for this one. Maybe I can show you. Let me see. Okay, it's not machining anything. Yeah, so this one uh, has a lot of things to do here. Since I haven't made any depth of drills, nothing here because my file mastercam file just crashed in. So let me show you the finished drawing real quick. Um, so this is the one. This is the finished drawing. Um, this one. Okay. This is the finished drawing that should look like this. It should look like this. All the toolpaths if you select Alt T again. And then I'll show you how it should look like the finished part. Tool components folder I want to remove. Shoulder 2. Okay. I just need a flute here and then verify. Go to color loop, home. Let me show you how the finished part will look like real quick. I will do the isometric and speed is slow. Okay. Oh, showing you the stock for this one. So I maybe hit the wrong one. It's selecting mill 1 operations 2. So I just need mill 2 operations for this time. And now we are good. This is weird. Okay, just 1 second. Uh, yes, it's still selecting these operations. Okay, now I think so. This should be good now. Yep. Let me zoom real quick. Okay, so this is our small pocket, and then it did counter the name engraving, all the chamfers and holes, and then the back side. The facing for the back side is done. And what is this? Okay, so this is for the large pocket. We have to make it like this since we can't take avoidance region, because it will show you an error. The feed time total is around 22 minutes and 12 seconds, and your finished part will look like this with all the reaming too. As you can see, the reaming here is okay. And if I remove the verify color loop one, I think, yeah. So our part will look like this. Okay. So this is our finished part. And that is it for the mill project too. And again, I am saying this that this is just with my knowledge, with all the Mastercam. It's not a fully completed project since there might be some more doubts that could occur in future and something might be wrong that I am not sure about. So I would say that you still consult with the professor what he thinks about all these toolpaths and this all offset kind of thing. And just let you know that some of you guys are confused that you have selected Hasmel 3x even if you are at home in your laptop. How can we do that? It is very complicated. I can make another video of that, but if you hit default, just go to files and uh, it says here file. It will show you default here. You can just go here and select it again. Okay. Uh, and that is it for today, guys. Thank you for watching and supporting me. Just subscribe to my channel, and I will post more videos for this one too. All the other projects too. Okay. Thank you so much.